All right, let's dive into one of Python's most, let's call them unique features. We're talking about indentation. And yeah, it can be a little frustrating at times, but it's not just about making your code look pretty. It's actually the glue that holds the whole language together. So let's figure out why.
You've been there, right? You've written some code, you're feeling good, you run it in, bam, indentation error. And you're just staring at your screen thinking, really? One space? How can one little space bring my entire program to its knees? Well, it might feel random, but I promise there's a really smart reason behind all of it.
So let's get right to it. Why does Python care so much about whitespace? It all comes back to a core design idea. This wasn't just some arbitrary rule somebody made up. It was a conscious decision to force us all to write cleaner, more readable code. It's a huge part of what makes Python feel like, well, Python.
And this is where it gets really interesting. Python's creator, Guido van Rossum, had this goal: make code that's readable by default. So he tied the program's actual logic, its structure, directly to how it looks on the page. By doing that, he basically made it impossible to write super messy, hard-to-follow code. The indentation is the structure. It's not just decoration.
And just look at the result. I mean, this says it all. On one side, you have a language that uses all these curly braces and semicolons, and it can get pretty cluttered, right? And then on the other side, you've got Python. See how clean that is? It's just obvious where one block ends and another begins just by looking at it. There's no extra visual noise. The layout itself tells the story.
Okay, so you might be wondering, how does this actually work? Is it some kind of magic? Nope, not at all. Let's pull back the curtain and take a peek at what the Python interpreter is really doing behind the scenes every time it sees your spaces and tabs.
So before Python even tries to figure out what your code is supposed to do, this little component called the lexical analyzer does a first sweep. You can think of its job as chopping up your code into little pieces or tokens. And it pays very close attention to the white space at the beginning of every single line.
To do this, it uses a really simple but brilliant tool, a stack. Seriously, just picture a stack of plates in a cafeteria. It starts with one plate for level 0. When your code indents, save for an if statement, it puts another plate on top. And when that block is done and you unindent, it just takes a plate off the top. Pretty neat, right? It's a super simple way to keep track of how nested your code is.
So, whenever the analyzer adds a new plate to that stack, it also generates a special little flag, a token called INDEND. This token is basically a message for the next part of the interpreter, the parser. It's like shouting, hey, a new block of code is starting right here.
And you guessed it, the exact opposite happens when you unindent. When a block of code ends, the analyzer takes a plate off the stack and generates a dedent token. This tells the parser, okay, that block of code is all done. And what's cool is, if you unindent multiple levels at once, it'll generate multiple dedent tokens to match.
Okay, so that's the theory. That's what's happening under the hood. But what does this mean for you when you're actually writing code? Let's talk about the practical rules you need to follow to keep things running smoothly.
Rule number 1. The absolute most important golden rule of Python indentation. Pick one and stick to it. You can use spaces or you can use tabs, but you can never, ever mix them in the same file. Modern Python will just throw an error and refuse to run. Just don't do it. It's not worth the headache.
So which one should you pick? Well, the official Python style guide, known as PEP 8, and pretty much the entire Python community have settled this debate. The standard is 4 spaces for each level of indentation. It's just the convention, and it's a good one. It makes code from different people look consistent and easy to read.
Now, let's talk about the mistakes that we all make. Seriously, every single person who writes Python runs into these. But they're not failures. They're just common traps. Once you learn to spot them, you'll be able to avoid them so much easier.
First up, trap number 1, the unexpected indent. This is basically what happens when you get a little too happy with the spacebar. You add a new level of indentation for no good reason, and Python sees it, thinks you're trying to start a new code block, and gets completely confused because there was no if or for to signal a new block. So check out this example. The first line inside the if block, a equals 6, is totally fine. It's indented one level. But look at the next line, b equals 5. See how it's indented even further? Python looks at that and says, whoa, why is this here? There's no reason for a new level, and it throws that indentation error.
All right, trap number 2 is the complete opposite problem. This is the missing indent. It's what happens when you write something that requires an indented block, like an if statement or a function definition, but then you forget to actually indent the next line.
You can see it right here. That line, if true, ends with a colon. That colon is a promise to Python. It says, hey, the very next thing you see is going to be an indented block. But then the print statement is at the same level. Python was expecting an indent, didn't get one, and so it complains.
Now this last trap, this one is sneaky. This is the one that'll really get you, because your code will actually run, no syntax errors. It'll just do the wrong thing. This happens when you forget to unindent a line, leaving it inside a code block where it doesn't belong.
Take a look at this function. See that return false line? It's indented, which means it's part of the if block. So it can only ever run if the number is even. But wait, if the number is even, the function already hit return true and quit. So what happens with an odd number? Well, the if condition is false, the whole indented block gets skipped, and the function just ends. It never returns anything. So you get none back instead of the false you wanted. All because of one little indentation mistake.
Whew, okay, that was a lot, I know. We went from Python's core philosophy all the way down to how it handles tokens. So let's just boil this all down into a few key things you absolutely need to remember to master Python spaces.
Here's your cheat sheet. 1. Indentation isn't style, it's syntax. It's there for readability. 2. Under the hood, Python is using indent and dedent tokens to figure out your code structure. 3. The gold standard is 4 spaces per level. 4. Do I need to say it again? Never, ever mix spaces and tabs. And 5. Keep an eye out for those 3 common traps: the unexpected indent, the missing indent, and that sneaky forgotten dedent.
So we've seen how Python takes a simple visual rule and turns it into a really powerful tool for clarity. And that kind of makes you think, doesn't it? If this one simple idea has such a huge impact on the language, what other design choices are baked deep into Python that make it so Pythonic? Definitely something to chew on. Thanks for joining me.